Hello there. Today we'll be doing number 64, finishing up all our tree median problems. Construct a tree from a pre-order and in-order traversal. This is going to be an interesting problem. It's all about patterns. But finishing this up, we're going to be moving on to tries after this. So in this particular problem, we are given a pre-order and a post-order. In order, and we're supposed to using this information, we're supposed to be able to construct the tree in its proper alignment. And this particular item is done via let's say, I think it would be called a recursion, where we would be looking at each item in pre-order, and then populating the information we need in order. So what do I mean by that? Let me just pull up an image. I think that's the best way to do this type of problem. We can't just, be funky about it. So this is our root, and as you can see here, these numbers here and this number here separates out the left and the right. And you might ask, why? Why does this number separate out? So what happens in order? In order is all the left, then you do the middle, then you do the right. Pre-order, you do yourself, you do the left, you do the right. So essentially, we get this pattern where we get it split straight down the middle. All the items that are of the middle and behind are going to be the left. Everything after the midpoint is going to be the right. With that piece of information, we can figure out many things too. So where is this particular item, the first item? Well, in the middle. Whereas this particular item, well, it's at this particular spot. Did I get this properly done? I'm not sure. This is pre-order. Yes, makes sense. In order, is it in order? Well, you go this way, here, you go left, and then you go middle. So this would be the middle item. Yes, that makes sense. And then this would be the next middle item. Anyways, it is correct the way it is. So what we know is that what's on the left side and what's on the right side. And we can find the middle and then get the left side and the right side again, and find the left side and right side of this as well every time we go to the middle. This is always going to be the middle item. This is always going to be the middle item every time we go. This is going to be a root, but we know. And this is going to separate between the left items and the right items for all our nodes. Essentially, it's understanding what pre-order and in-order does very well, to the point where we can reconstruct the tree from our pre-order and in-order. And the code is very simple. So if we do an if in order, if there are items in the in-order, what's going to happen is that we're going to set our root equal to our pre-order, the first item, 0. Then in the in-order, dot index of the root, we found that is our midpoint. That is the point where we split the items. And then once we found that, what's going to happen is that we're going to set root dot left of this item. Of course, this is going to be tree node we're gonna create a tree node of this particular value. My bad, and we can't use roots here. How interesting, but we can do that. Anyways, point is, root.left is equal to build tree. We're seeing a pattern there, so what we can do is preorder everything from the 1 onward to mid plus 1, because we have to offset for that. And now, in order, and we're going to take everything up until the mid. Let me check the image. Yes, everything up until the mid. Makes sense? So root.right is equal to build tree of preorder again. And here we're going to start with mid. Let's see, was it plus 1? Yes, mid plus 1 onward. And in order, we're going to take, is it mid onward? I don't think it's mid. This is mid. I think it's mid plus 1. Start from the mid. No, we don't want that item anymore. I think it's mid plus 1. I might be wrong though. You know, it happens. Okay, so mid plus 1. So then we can return the roots afterwards. Run. If I'm wrong, this should be wrong. Let's see. Build tree in order. Wrong syntax. What the heck happened? Oh, right here. That was bad. Run. Runtime error. Build tree is not a thing. Self.build tree. Self.build tree. Run the code. Index out of range. That is odd. Is it because of this? Whoa. Oh wow. Okay. I think that's interesting. So it was in order was mid. Wait, wasn't this mid? Oh, everything up until mid. Makes sense. Okay. There we go. Anyways, there is a faster way to do this. It is popping this particular problem. And it is also pretty interesting. So let's do it. So we're going to set the index is equal, the mid is equal to the in order dot index of the preorder dot pop. So I think it was pop 0 because we're trying to pop from the beginning of the list. So and then we set the tree node to mid dot val. Pretty cool. Okay, so well actually this is a list of integers, so just throw mid in there. Tree of mid. So with that we can set root.left, root.right, but this time, because we have popped already and we're just going to do the left in pre-order, so we're going to get all the left done, and then we're going to do the right and everything. So we just need to split the in order, I think. Oh, shoot, that was not right. Let me get back to you on that. Let's see. I'm not so sure anymore. I had some notes on this, on how to do this, and like it's that's what I'm missing. No, still wrong. Mid. Ah, right. Interesting. So this is the index of the mid, and this is actual mid. So then we submit it. So why 0? I'm not so sure about that. Let's run the code again. I'm not very sure about why it's set to 0, but it's so much faster this way. I think it has to do with the preorder not be it's in its natural form where it's being popped without like doing a lot of splicing. I think that might be it. So let's see. Okay, so basically what happened here was that we created the mid from that particular. We got the index and we got the midpoint, but we did not get the root item. That's why we were not able to get the root. Then once we did, it's basically the same operation before, but the preorder has been popped all the left items, and then we did the right items in the proper order, of course. And so we did it in preorder. So following the natural order, we were able to just throw in preorder without mucking around too much with the code. And that way we reduced the runtime by like half. And so yeah, that's it. Again, it's the most important thing is to draw it out. Like that's the most important thing here. Whoops, where are my notes? Yeah. So my notes said that, I mean, like you have to draw it out and look at the patterns when you're looking at this type of problem, and to see where there is a point of like, you know, I just ask a pattern where there is a pattern, and you could use the pattern and build up the answer. So it's I don't think you would be able to like generally, if you haven't seen this problem, it would be very hard to do during an interview, especially if you're trying to do this. Even if you had this, you drew all this out. I think that's a very good progress. Finding that pattern and this particular pattern here where they're equal, and finding that item in here and that item in the middle as well, and so on and so forth, and cutting each item up, and then you have the 4 and 5, and then you have the in order to the left, and then you have the right, and so on and so forth. Which is, I think it's pretty good. I don't know if seeing it the first time will you'll be able to solve it quickly. It'll be very difficult, I think. From my perspective, it's very difficult. If you haven't seen it before, but look at all these excepts for some reason. Anyways, but I think that's because I've looked at Neetcode's video to help myself understand this problem more quickly than not. Of course, none of this code looks like his code. This is I looked in the discussion section to simplify this, and this was a lot of trying to make these observations. It's about yeah, it's about writing it out and observing, and that's how we solve this particular problem. Anything else? No, I think that's it. Okay, well, I think that is all for this particular problem, and that's we learned a lot about how we need to observe, and what we did observe was that we needed to split the list in between, and by splitting the list and splitting the items in half, and we're able to find out where does the item lie, on the left side or the right side of the particular root node. If there's nothing, then there's nothing on the left side of this 3. It's null. And if there's nothing on the right side, all on the right side of this item. So that's what we learned And that was great. That is very good. I think looking at this problem multiple times would help even more. Trying to you start observing more and more patterns. It just happens. Well, anyways, I hope you learned something today. If you enjoyed the video, like and subscribe. If you want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.